just wouldn't be a Twitch stream without some kind of bug.
772. Let's increase bitrate to 1.5K. Apply. Okay, now we're talking. Now it's working fine. I don't know. Last time it capped to a different bitrate and it had huge latency. It's silly. Okay, that's good. And let me change back to 30 FPS is fine. Okay. So what do you see now? Project, right?
Yep, project 1.
Okay, switch to project 2 and tell me when you see that I switched to 2.
Alright. Switched.
Okay, so 7-ish seconds delay is good. So back to project. Yeah. So about project. A single project can represent a whole application. For example, Windows Forms. You can have everything there if you want to. So your application is at least one project. Usually it's more than that, and I will introduce that a bit later. So your project is made of a bunch of files, a bunch of code files, such as your code that you execute, CS files, then configuration files, your UI, and so on and so forth. It varies per type of project you have. So for example, application for Windows Forms can have 2 projects, where you have your UI in one project and backend logic in another project. This is how project looks like in Visual Studio. Like if you explore and expand your project, you will always see references. So first you see project name, that's basics, references, basically stuff that your project uses, and configuration file, basically stuff which you can change without running your program, without changing code itself, something that can be deployed and doesn't need to be compiled. It's simply read every time from your application. So config, references, code files, and project name. And so application is made of projects, and in this case we have a game which is made of core and presentation. So what that means is that we have a presentation, some UI, which use core game logic in it. So if we would expand presentation, we would see that it references to core project. So application itself is something that has to have some sort of executable, and it has to be one of the following. A project doesn't have to end up being something that outputs this, but if we are talking about application, it needs to be some sort of executable that you could run and use. You cannot run raw code, for example. It needs to be through some sort of interface. And last part of your code structure, program structure, is solution. And solution is something which has one or more projects in itself. So solution is the container which stores all your projects. So project stores files related to code, and solution stores projects related to the applications you're developing, application or applications. So at least one project is in solution, and solution usually contains applications, related applications, but it doesn't have to be that the case, because a solution can simply be a bunch of class libraries which other people will use. You don't have to use it right away. It depends on your intention. And why am I viewing it like this? I should view it like this. So solution. In Visual Studio, solution looks like this. You have a solution name, and then you have a bunch of projects. In this example, we have 5 projects, and those 5 projects are actually split into applications. One application is game, and then another tightly related application is spell editor. So our game is where you cast magic, and our spell editor is where you can create your own spells, so it's complex enough to have its own project. Backend library for backend code of your projects are usually in class libraries. They're supposed to be there. If you want to nicely split it, and your presentation, which is for example Windows Forms, VPF, console application, it should be as stupid as possible. It should have as little things as possible. It should have only interaction logic and nothing more. And the actual logic for your application, the most important business logic, should be here in those class libraries. How does a library look like? Well, it's a DLL basically. DLL translates to dynamically linked library, and you simply reference it. And I'll quickly go back to a project to show how a DLL looks like. So those are the projects that we reference in the slides. And if you, let's say, build solution, it outputs something. Build succeeded, and if I open my solution and I go to my source folder, and let's say I open my game core, and if I go to the output, you can see this file, and this file is a dynamically linked library. It's a DLL. So if I wanted to use this in another project, I would have to reference it. How do I reference this DLL for to another project? So my project that I want to, so I can reference it in 2 ways. Since I'm working on projects which are in the same solution, I can reference a project itself, or I can reference a build, so a DLL. So let's say I want my presentation to use spell editor core, and if I wanted to do that, I would go to references and hit add reference, and if it's a project from my solution, I select this, and if it's not a project from my solution and just a DLL that I want to reference, I would go and browse to it. I would browse to that DLL. So in my case, the DLL is here. Bin, debug, and then I select this. The moment I select this, a reference is added, which I already have because I reference a project. And this means that I can access code which is inside that DLL. So that's how you add a reference, and that's how you use a DLL.
I have a question.
Yes? Go ahead.
If you add the reference manually in the solution, does it only work if it's in the same solution? Because, like, if you browse it, you can
Yeah.
get a DLL from wherever on your computer. But if you add a reference inside the solution, it has to be like in the same solution, right?
Do you mean that if I reference something which is where the solution is, that something has to be somewhere in one of those folders which is inside the solution, right?
Yeah.
Yes and no, because when I built this, so I added a reference, and for this time it is in solution. I built it.
Yeah. Okay.
I think what he's asking though is if you reference a DLL file that is in a different solution from the one you're working in, or just a different location on your computer altogether, does it create a copy of that DLL and put it into the solution you're working on, or do you always have to have that same DLL file somewhere on whatever computer is going to ultimately be running the application?
So the answer to that question is that when I delete everything and I hit build. And so what do I need for this to work? For this to work, since I reference the core, it will copy the core as well, along with the stuff that gets built from this application. It copies also the application that I referenced to, the DLL.
Okay.
So whenever you have a reference, and whenever you call something that you reference from another DLL, that DLL needs to be physically present from the place you call. So if my exe calls something from this DLL, they all need to be in the same place physically. And reference will ensure that it's there and that it's physically created when I call it.
Okay, okay. I get it. Thank you.
And it can be referenced from anywhere. It doesn't have to be in solution. I can have it in my documents. Doesn't matter.
Nice.
And Philly JW said that there are multiple ways to reference a library. A library can be a class library or DLL file or a system library. Yes, that's true. Personally, I haven't worked with the others, as I find that DLL is the easiest and most common way to do it, but please correct me if I'm wrong. When you create a solution, you can have multiple project types and multiple class libraries. You have .NET Standard, you have .NET Framework, you have Legacy Portable, and so on and so forth. The different things you can do, different types. Right now I'm just focusing on most basic cases and most usual cases that a developer would do, a .NET developer would do, working with C#. Actually working in general. A thing to note, when you create a DLL, which is made with .NET, you can access it across all .NET languages. I could use something that was made in VB.NET from C# and vice versa, as easily as referencing a piece of DLL, a DLL. So it doesn't take much to reuse code, as long as it's across .NET.
And the fact that they could be written in two completely different languages wouldn't cause a conflict?
It would not.
Because it's like
it builds the same thing.
I did not know that. That's interesting.
Yeah, it's a very cool thing. For example, at work I have to do something in VB, and I only work with VB because the base of project is in VB. But I don't like VB as I'm used to C#, so I write a DLL in C# and then reference it from VB, and it works. Okay, and actually even something that's not made with .NET Framework can be used in .NET Framework, but it's a bit more difficult process and takes longer to get a hang of it. Alright, let's continue. So every program has a starting point. It has to start from somewhere. And every program has to have at least one function, because a function is something that says what needs to be done. It has some commands that it calls. And for that reason, a program is something which calls some predetermined commands that we define. That's why at least one function. And that's why a program has to have a starting point to create itself, to bootstrap itself, to build a UI or to give us a display or execute a command that we want. So console application has a static void main where you pass some console arguments. Windows Forms has a main method too, which looks a bit different, but all it does is it creates the main form that you created. That's what the main does, essentially. It says that it will be visualized, rendered, and the form will be created. VPF is a bit more complex as it's a newer thing. It has a more clear architecture. So what it does essentially is has an event handler. So in this case we have on startup, and on startup will be called when we run our application, and when we run our application it will do its things like creating the UI, registering and initializing stuff, and so on and so forth. So basic. Now let's move on to a more interesting thing, which is basic code syntax. So the most basic code element is a variable. It is defined by three things essentially. We need a type, a name, and a value. We don't have to write a value right away, as it can have a default value if you don't set one. For example, a number defaults to 0 if you don't define a value for it, set a value for it. A string defaults to null. Logical variable, boolean, defaults to false. And here are the basic types for C#. For whole numbers we use integers. For floating point numbers we use float. Floating point numbers are the core type that you will use for numbers when you don't care, when you just want a number which is not a whole, because it's the fastest and the precision is good enough. But when you care about precision, you have to consider using decimal, because losing a fraction once won't matter that much, but when you do it millions, billions, trillions of times, it accumulates to a really noticeable loss, and that's why people use decimal for numbers or scientific calculations. We use string to store text, and we use bool to store logical variables, conditions, values which are binary, in other words, which could have two values, true or false. So that's about types and projects for now, and we will move on to functions, and with functions I'll go to solution. Do you have any questions?
Are there still variable types that are in other languages too, in C#, like double, long, single, things like that?
There are, of course. Each language has its own system for types. .NET more or less has a unified system for base types, at least. You mentioned single and stuff. I think C# has it, maybe not. Yeah, C# has it too. .NET has it too, I mean. So yes.
Okay. They're just not very commonly used then, I take it. The the ones that you had listed off are what we're gonna see stroke used most often.
That's true. Those are the basic ones. And a question about f in the end, and I will explain this with this example. So here we have a float, and say we don't have f in the end, and we see a warning, actually an error saying that we cannot implicitly convert something which is a double to float. So by default, by default, uh, numbers are um, doubles. This is the type that a number defaults to. So a double. I'll actually make this full screen. So this is double, and this is float. The problem here is that double is higher precision than float, and we have here a double which we want to automatically convert to float, and it gives us an error because doing that would cause a loss of a fraction for that number. If it was something like this, some part of the number, like this part, would just drop. I'm not sure about exact numbers, exact precision, nor I ever cared. I just know that float is a floating point number, double is, I think, double the float precision, and decimal is double that. Actually, something that doesn't really change the floating point. So by adding f, we specify that this is a floating point number. By not having f, this is a double which gets converted to float. So we lose precision by converting from one type to another, and that's why it gives an error. F is equivalent to this. Just a shortcut for casting to a float. Casting means converting to that type. Explicitly converting it. This is implicitly converting it. And I cannot implicitly convert it because it would result in loss of a fraction. I hope that answered your question. So this is double default. M is for decimal. My mic has changed.
You still sound all right to me.
Maybe it's on your end. I hope. Am I? Do I sound like I'm in space?
Not that I had that problem with Discord last night. I had to leave the voice channel I was in and came right back, and the problem went away.
Oh.
At least in my case, it was client side.
Quiet. Okay. But right now it's fine for you.
Yes.
Okay.
I don't know about anybody else that's tuned in, but for me,
well,
it haven't changed.
That means it's a concern of the other end, not mine. Okay. So this is how a basic types and functions look like. Now let's go to, so this is how basic types and variables look like. Now let's go to a function. A function, and basically stuff that you'll see in literally every code file in C#. Every. So here it is. We'll start from the most simple things. 2 slashes will result in a comment, and anything that's commented out will be ignored. this, I actually should have swapped it here. This is a namespace, and what the namespace is, it's a place for a project. It's a virtual place for this project where your code is put. So by having this this namespace, I'm saying that in my project, in order to use this this piece of code, I would have to reference somehow this namespace, this location. For audio, I think I can do one thing, as I can increase audio bitrate. The streaming audio bitrate will be set. Okay. Change something, maybe it'll help. Anyways.
So really quick, when you reference that namespace, that one specifically, is that a reference to the DLL or just to the project that has that name?
Neither. It's a reference to something which is in that DLL. So in our case, we have this DLL. So it would be inertia mage spell editor core, and this one here references that project level reference, and this one does a using. So it says I'm using something from that project. I'm using this namespace. I know that this namespace exists because I referenced the project which has this namespace. So by referencing that project, I get stuff. So when I reference this namespace, I get stuff which is inside it, and I can reference it because I referenced the project. A question. Wait, so you use namespace as opening scope? Yes, that's true. All code that you have in the code file will be inside some namespace, and this is because you want to use that code, and in order to use that code you need to reference the namespace. You reference namespace using a using keyword. So it says I'm using this namespace, and if I go back to the core, not this spell editor core, here you see that this is the exact same name of a namespace that I use, that I'm referencing, that I'm using. So this is how you create reference to a code so that you can use it. And you said never mind, but yeah. CS is extension for C# code files, and this greeter class is in greeter.cs file. Can I refer from project to project? And the answer is yes. So basically I have one project, inertia mage spell editor presentation console, which refers to inertia mage spell editor core. Two different projects, and I'm using code from core project in my console project, presentation console project, and I am using code from it using the using keyword. Yes, this is actually already a reference to DLL, I think. By adding this, it's a project reference. By doing this, it's straight up DLL reference. but in the end it ends up being the same. Alright, let's go back. So this is our namespace, and the thing about namespaces that they usually match physical locations. So I have a project, inertia mage, spell editor, core, and then I have namespace, inertia mage, spell editor, core. They usually match the location of a file, physical location of a file. They don't have to match, but it's a good convention to have them matching. The DLL part. Is C# building a DLL eventually? Yes, C# is building DLL when you have a class library. Your program needs to have some output of your code. And for class library, it's DLL. For executable, it's just DXC. For Windows Forms, for example. It doesn't have to be DLL. Yeah, exactly like Phil said. Everything is either some sort of exe or DLL. And your exes use DLLs. Let's continue. So that defines a namespace. A namespace is, so our solution has a scope. Like, you cannot use stuff from other solution, like stuff that you can use it, but you cannot use it by default. So by default, everything that you see in your solution is here, those projects. When you open your project, you have your project scope, those files and properties and settings. And those files and properties and settings are not visible in other projects. For example, properties of this project are not known to this project unless you do something. You need to work with it, you need to connect them somehow. And in most cases, for something like that, you don't really care. You just want to reuse code between them. So you have different scopes. So a solution scope, project scope, and then when we go into code, we have a code scope. So our code file, the first scope that our code file has is the namespace. So anything that is outside the scope is not visible to other things. This scope knows only about these things, unless you say otherwise with a using keyword. By default, it would know only that this thing has. So it will only be able to do whatever this namespace has. Namespace can have same names in different files, and that would mean that by default, having same namespace of different files, I will just put something like a new class. I'll call it person. Don't mind me writing stuff right now, as it doesn't really matter. But I have a person class, and this person class is visible in greeter class because it is in the same namespace. Two files, but same namespace. The thing I mentioned about namespace, it matches physical location. This basically means root of the project because it matches the project's name. So those brackets define a scope. If you go outside those brackets, curly brackets, you don't know anymore by default what the scope contains, unless you do some stuff, for example, the using statement. Alright? So that's the first scope of your code, namespace. Second scope of code is a class. So if I have one class and if I have another class, so I have two classes in this example, greeter and internal greeter. this class knows nothing about this class because it has a scope. Only stuff which are public can be called from another class. Yes, question about green lines, green text. 2 slashes in C# equals a comment. And a comment is something which gets ignored. It will not be executed, and it's purely for a note for for yourself or someone else. Okay, so let's continue. We have a class scope, same rules apply. You don't see anything outside scope. We have function scope, same rules apply. Now let's go back to a class. A class is your holder of code. In C#, you cannot have a piece of code, a piece of commands, without putting them either in a class or in a struct. In most cases, it will be a class. So we have a definition. So in order to define a class, you need to have 4 things essentially. Three things essentially. You need an access modifier, a class keyword, and name your class. Static means that this class cannot be instantiated. It means that it's like a holder for your code. You can call greeter and directly call code. If it wasn't static, you would need to create an object and then call methods from that object. And public means that this class can be accessed from outside the project. That's what public means for a class. By default, classes are internal. If I don't have this, like here, you don't have access modifier, it's not public, it defaults to internal, meaning that this class will not be accessible in other projects than this one. Alright, let's go to function. A function, very much like a class, is defined first with an access modifier, then with the way we intend to call it. Static means we call it directly from a class, because a class with static cannot be created. So a static method will, every method in a static class will have to be defined as such, as static. So then we have a return type and name of a function and inputs, some variables which will go into that method and which it will use to work with. In our case, we have a greeting function which takes person as a string input, and then we format the greeting. This might look weird to you, but all this does is enables this curly braces. So the equivalent of this is like adding strings together. Those 2 lines are equivalent now. So, oh, also exclamation mark. So what this does, it inserts string in this, inserts a variable in this string, and this adds together. Essentially they're the same. So again, this dollar means that I can write those brackets, and those brackets get a special meaning. So in this case I wrote it without the $sign, and in this case I wrote it with $sign. So in this case I had to add person together. So I had to add hello and then append person's name and then append the rest. And that's how I built a greeting. And in this case, all I had to do is those brackets, and it slipped the person in the middle of string using those brackets because I put the $sign. It's called string interpolation, a language feature that C# supports.
So does the $sign take the place of, say, the ampersand in Visual Basic for concatenation, or is that something completely separate?
How would it look like in Visual Basic? You can write code yourself.
Okay, so like for example, here let's see if I can throw this together really quick.
VB, yes. And yes, and is the same as plus in C#. But I don't think that was the question. Oh, it was. Okay, sorry. Yes.
Yeah, that was the question. I just wanted to know if the $sign takes the place of the ampersand. Okay, I will remove this now.
Okay, so now we see that we have an error, and we have an error because we have two variables which have the same name, and this causes some ambiguity, and you see an error saying that we have already a variable which is declared the same way. So we have to remove it and keep one. We cannot have variables with same name in same scope. Alright, so our function returns a string, a piece of text as a greeting. And we return stuff with return statement. If I had this, it would be ignored. It would be ignored because return statement ends the function. Return statement will go back to the place the function was called from. And that's why we'll go to a print function which has void as a type for a function. Void means that it returns no type. No value needs to be returned. But let's not forget that the function needs to go back to the place it was called from. So I call a print function somewhere and return basically at the end of a function it will return to the place it was called from. I could write this, but it would be redundant as it does that anyways by default in function which is void. So that's a return type. So a function will always return to the place it was called, and it will not return with a value if it's marked with void, but it will return with a value if its return type is something other than void. And again, static means that this function can be called from anywhere. Not from anywhere, but without the need of an instance. So I can say greeter dot and call the function. An example of that is here. Here I say greeter print person. Greeter greet person. Alright, that's that. Now let's go to an interesting function. We have two functions with same names, and we could think to ourselves, hey, they're very similar, like same variables, same names, so we have same functions, same names. How does a compiler know, not compiler, but how does runtime understand which one needs to be called? And the answer is very simple. The only difference, well, the only major difference, I could make this public too, the only major difference that these two functions have is that they are having a different input. This greet has a person as input, and this greet has no input. What this means is that that if I go here and I say greeting 1 is this and greeting 2 is this, it will know what I need, because here I pass a person and here I pass nothing. So there's a clear distinction between the two, and it knows this based on the input. So runtimes knows this based on input, and this is called method overloading. I could say that this is greet 1 and this is greet 2, but that would be useless, as we have methods which can have same name but different input, and this is called method overloading. Alright, that solves it. What else did I want to say? Right, before this function had no access modifier. For a class, access modifier here defaults to internal, meaning that I cannot access it from from another project, from another assembly, in other words. And for a function, default is private. This is the same as no access modifier. And a private function cannot be accessed outside of the class. It's local to the class. It's local to the scope it's in. It cannot be accessed outside the scope. So if I try to call greet now, you'll see that actually you'll see a weird error saying that it tries to call greet with a string inside, but it does that because greet without parameters is hidden now. So it's private and you have no access to it from other classes. Other assemblies or classes in general. And if I did internal greeter, I don't even see it. Let me go there. Greeter, internal greeter, and try to do the greeting. And I'll say also person. So again, you see, cannot access internal class here because it's only visible to the scope of the assembly it's in. Internal means you cannot access it outside. Okay? So that's a function and that's a variable. Do you have any questions? Alright. So we now know how to write basic variables, and we know how to call a function with some input, without input. And this is actually the scope of this lesson. So now let's make some exercises. And here we have a question: is the $sign way of formatting considered a good way in C#? And the answer is definitely yes. Let's go back to the person. Essentially, you have quite a few ways of how you can format it, but essentially this one is the best and this one is the newest way of formatting in C#. Second way before that was when you have a greeting, you could do this, and this I think is the way it's done in C++, if I'm not wrong. And you could do something very similar as that one. I think this is how C++ does it too, but I might be wrong. Person, smiley, and we put a person. it does allow string as well. And string is the same as string, except it has some... It's a relic of Java, I think. As Java has string as a capital letter, and since C# copied Java, it copied that with it. But it's essentially same thing. String basically wraps string. That's all. I don't think any of them is an object. Well, actually, everything in C# is an object, so technically yes. But yeah. Or people who write Java, and if you consider people who write Java insane people, then maybe. Yeah, it does. So it's a part of something that's a bit deep. Okay. So this is how you would do string formatting before string interpolation, and before this you would do it with the plus sign, like we did it initially. With the plus sign, where we add person all the way there. Okay, and there. So it's very tedious to do it every time you want to add strings together. So you see, this is more work, this is less work, and this is the least work. So you can clearly see the benefits. Yeah. And that's why C# is a beautiful language, because it has so much of this syntactical sugar that it lets you do stuff so conveniently, like string interpolation, like limku, like lambda, and so on and so forth, like properties. Alright, now let's go back to testing and seeing how it works. So if I hit run, it runs my console application. It closed it immediately because I didn't say it not to otherwise, and I should do read line or just read. And if I run this now, it will greet a person saying it's Tom. Actually, it will print person's name as my greeter print function writes the console. And if I hit enter, it stops it. Okay. Right. So that's how it looks like on a console application. If we did the same in our Windows Forms application, let's add a person too. I still ran the same thing, and one thing that you might be confused, that how do you change a project which you run in Visual Studio? You change it here. So it lets you have a choice of which executable you want to run. Or if you prefer a more manual solution, you can right click on solution and select the project you want to run from there. Or if you want to have a more complex build and check, you can run multiple projects at once. For my case, I want WinForms, and I'll do that. And I just ran it, and you see that the text was not written anywhere, but it actually was. It actually was. And how can I see the output window? The output window, output pa, pa. It should have printed it somewhere too, but I'm not sure where in this case. Anyways, when you want to print something in a non-console application, the console.writeLine will be executed somewhere else. And you will not see it unless you explicitly look for it. So it's not something that is user-friendly. So how would you display this in a Windows Forms application? Well, we could go to add a label or something from a designer and set that to whatever we want. Somewhere. And set it to what we want. Okay, person, greetings, person. I wanted to not print this, but to return this in a label. So I can explicitly have this here, put it there, and print it there. This is not the right way to do it. What was the label name? As I am supposed to do it from the form itself. I actually will do it from the form itself. Since it makes this one actually in Windows Forms should not be touched unless you do something which will happen only on across the whole application for all your forms to register dependencies and stuff like that. But right now we don't want that. View code. So here we initialize our component and we greet a person. So we say that label 1 text value is a greeting one. And if we run now, we will see that it set the label to what we wanted. And basically identical will be in VPF, except in a different place. App creates a main window, a bit different way of starting it up. But when we initialize our main window, we can also create the label there. So if we put to label here, it's name. I'm not sure what the name will be. But now I am. Set value. The meaning of this square some kind of decorator, and the answer is yes. It's called an attribute, and writing those, you were by saying decorator, you're very spot on, because writing those next to a method or a class is called decorating. So it's an attribute, and writing attributes to your methods is called decorating. STA thread means that it's single thread application, single thread apartment thread, and what that means that it's specifically designed to run on a single thread, I think. haven't gone too much in detail, but I've had problems with mixing that with multithread. And since Windows Forms is heavily based on a UI thread, probably that's why you have the attribute there. You don't see it in VPF, but probably that also exists under the hood. Yeah. All right. Now, why can't I set this value? No. Damn it. Initialize component. This is also something deeper. Label 1. Shouldn't be that hard, come on. Value. Set value. Dependency property. Dependency property key value. Nope. Dependency property key. Dependency property I actually don't know. Maybe a text box would be much easier. I am not sure how you do it in VPF. Does anyone know maybe? Anyways, the point is that presentations differ in projects, but I'm using the same code base from one project and another. I use the same spell editor core in VPF, WinForms, and console application. Alright, next I wanted to show one thing, just some way how you can easily slip and mess up. If you have a project, a solution, I'll close it right now. So if you have a solution and you have a project and suddenly something changed, like you wanted to rename your project or moved it to another location or change a project it's in, like this for example, I call it and add 1 in the end, and then you open this again, you will have problems because your solution will look into the same path to open your project, and this can be frustrating when you face it the first time, when you don't know what to do. And the thing is, you cannot really solve it from solution properties, and you might roam around like this and it might be tedious, but there is a way, an easy way how you can solve it, and you can solve it simply by editing this with Notepad and changing the path to anyone. So the change we made is we added 1 to presentation. So the change we should do is add one to each presentation as well. Console VPF informs. If I save and open again, it will, the paths got updated, so the stuff got loaded. This one probably still has a messy path as I messed it up, but the point remains that this is how you can easily, okay, a typo, but the point remains, easily fixable, can be frustrated if you don't know what to do, but a common thing that people do, and an easy fix. I don't want this, I don't want this, and I don't want this, and I will delete the one in the end. So that's it for this lesson. For the next lesson, we will look into loops, collections, like how to store something of many, and logical control statements in code, if statements, switch statements. So that will be the focus of the next lesson. So that's it for this lesson. Do you have any questions?
With regards to what you just mentioned about collections, I know it's in the next lesson, but I want to ask before I forget the question. Are collections and arrays the same thing, or are they different from each other?
Well, I kind of referred to anything that can be stored in a form of one variable, but like you store many of the same type in one. I referred to as a collection, but I was actually just using a wrong synonym. A collection is a type in C#. You have iCollection interface, which can abstract away collection in general. So the short answer would be no, it's not the same. Array is not a collection.
Okay.
I will talk about lists, generic collections like lists, a dictionary, array, and that's it. What regards to different types, different data structures used to store something of many. That's the ones I will introduce in the next lesson, along with while, for each loops, and switch and if statements. So yeah. Now the question is, do you, I would like to give homework. Would you like to do homework?
Depending on what it is and if there's time.
So I didn't really say how I plan to continue the series and go on with it. So basically what this will be, it will be a project, well, an application of two parts. One is very simple, it's like a spell editor. You will have a spell. So a spell has many properties, many things, and it's quite a complex entity. It's quite a complex object, and there will be an application where you can customize your own spell, pick a texture, particle effects, icon, and so on and so forth, and then export it in some file which you could import in your game. So the second part is a game. It's a spellcasting, first person, physics-based game. Which will be done in Unity. So in in that game you will be able to import your spell files, read those, and use those spell files, maybe create those spell files directly in game by calling the other application for editing spells. But the point remains that you create spells, customize them, and then use them in the game separately. For example, a spell could be something that makes you jump really high, something that makes you throw a fireball, something that creates a wall, something that does a big AoE, something that boosts your speed, and so on and so forth. So yeah, and a homework. What relates to homework? It should be that you work on this project and do something related to this project via a pull request in an open source way. And I made a video on how you work on open source projects the last week. And if you have any problems, if anyone has any problems, I could guide you through how to work with open source projects. Basically, how to work with a project that you do not own yet, which is public. So I would like homework to be in that form. It's harder to do once, but once you do it once, it will be quite easy. So would you like to take part?
I'll certainly give it a try.
Okay. So the first task will be to simply in a function list a bunch of properties that you imagine a spell should have, and then write a function which would take all those properties and print them. Well, one function to format them in a string, and another function to not print them, but display them in as a label, let's say, or as a text box or something like that. So that would be the homework. I'll write it down and I'll post it in the lesson channel, and I'll keep on posting homeworks there. So it's a very easy homework, and the second part would be create a Git repository, which is way more difficult task actually, and fork my repository and create a pull request. That is way more difficult, and if you have struggles with that, let me know and I'll guide you through. So that will be the homework. About Git, do you know what Git is?
Like get something from somewhere, or is it GIT?
GIT.
No.
So Git is a website. Actually, sorry, Git is a versioning system. Git is a versioning system which is to store your files on the cloud, your code on the cloud, and keep up versioning them. And you use Git because you don't want to physically have your files in some place. You want it to be safe and sound somewhere that has zero to very little chance of disappearing suddenly. So that's why we have Git, a system for versioning our code, and it's free. So we have Git as a versioning system, and GitHub as a provider, as a host for that versioning system. So GitHub is a website to which you can for free create an account and publicly work with your projects. So you would need to create an account on GitHub and then fork my repository, which which essentially means you clone my repository, and then you create a pull request, which essentially means you made a change and you would like to merge that change to my repository, to my code. So that's what the homework will be, and that's what Git is used for. And to demonstrate you, I use Tortoise Git to manage it easily. So the first step will be you will click, if you have Tortoise Git, you will hit git clone in an empty folder, and it will if you, let's say you go to, which one is it? Why don't I have it? Refresh. I don't see it. Tests this spot. Okay, weird. Anyways, if you go to GitHub and you see this button, clone or download, it will give you a link to your repository, which you need to enter. And if you go here to an empty folder and hit git clone, it copies something that's in your clipboard, and you hit OK, and then it copies all the files and links your local folder with remote repository. So the next time you make changes, so like I did, I made changes, I hit commit, I select the files that I created, that I changed. I actually have no idea where I commit, so I would like to check, but okay. So we added those files, and I would like to commit. So this is our first commit, second actually, after initial. So I will call it lesson 1, variables and functions. Variables and functions. And second step is pushing. Commit means you said that you made changes locally, and push synchronizes your local repository to remote repository. And those green ticks means that it's synchronized. If I go to show log, it shows the stuff that I did, the messages that I sent. But now what puzzles me is, where is it? Repositories. Okay, here. So I just opened my repository, and I can see the source and the projects and the changes with named commit, named changes that I just made. So this is GitHub, and that's what it's used for versioning your code, for not keeping it local, and for collaborating and working together. So I'd like to be able to have code that you send me through GitHub via a pull request. A pull request, what you need to do for a pull request, if I go to a random GitHub repository, like I hit explore, I click a random repository, and then I say pull request, fork, sorry, not pull request, where was it? New pull request. Fork, I don't see fork. Here, sorry. Here is a button to fork. So you fork their repository, which essentially makes a clone of it. So it made a clone of their repository in my GitHub profile. And the next thing I do is clone this as my own. I make changes, and then And then when I made my changes, as you see, this is now in my almantask kitty instead of this guy's kitty. So now I can do something called a new pull request. So I select my own. So it takes this from my own branch, from my own forked version, and I say that this will be merged to the master. If I do this, it will say no changes. So you will make your local changes and you will select your master branch and you'll merge it to my master branch. So your project version will be merged to my project version via a pull request. So when those changes are apparent, when they exist, you just input what you did and you send it, and that's all. So this is how you do a pull request, how you fork. This is all shown in slides actually, in a video too, and it's quite simple, and if you have problems I'll help you. But it's something that you should know how to work with if you want to be a competitive developer who doesn't get lost in the industry, working with various projects. And it's literally impossible to work without it in open source. So yeah, that's it for this lesson. Thank you for listening and watching.
Cool. Thanks for doing the lesson. That was really interesting.
You're welcome. Do you have any advices how this could be improved? Something that you didn't like maybe?
I mean, it's a purely beginner's lesson. So, I mean, I thought the pacing was good for that purpose. I mean, I have to imagine somebody who's much more advanced in using C# or maybe someone who already knows how to create an application in C# but is looking to add to their knowledge would have probably, for lack of a better expression, found it slow and boring. But for somebody like me, for example, who knows little to nothing of C#, it was perfect.
That's very good to hear, and that was the target audience. So the way I'm planning to proceed with the lessons is that I will go through the basics, functions, variables was today. Next week it will be how to store something of many, loops, arrays, ifs, switches. So that will be the next week. The week after will be already using a class, so that will start the interesting things, how to work with object-oriented programming. So the first 2 weeks will be very basic stuff, and the next after that will be more interesting stuff, how to work with objects, the beauty of C#, of object-oriented programming language. So yeah.
Okay. Alright, and I'd heard of GitHub before, but I'd never actually seen, like, I'd only ever heard of it insofar as places to download user-made mods for various games.
Mm-hmm.
So it's interesting to see what exactly it could do, and as a matter of fact, for stuff that I'm doing in my job, my day-to-day, this is actually very, very, very useful.
Yeah.
So I appreciate that. I'm gonna try and find that video that you had mentioned where you showed how to clip or how to fork
It's
into the
how
thing.
to work with Git in general. Everything you need to know
Gotcha.
about Git. Everything, literally.
Gotcha. Okay. What's the name of this particular project? It's not Japanese crossword, I don't think.
No, it's the same as written here. So inertia mage, it's called.
Inertia mage.
So you fork that one, and actually, so I forked the guy's repository, and it doesn't really matter because I didn't do anything to him. It's the same as downloading his stuff, except I did it in a more fancy way as I immediately created a repository. So it's as if it's my own project. And,
Gotcha.
And
Okay, so it's then once
here,
I'm in the repository, it's clone.
Yeah.
Okay. Is there a desktop application I have to download for GitHub?
You don't have to. You can either work with console or with some application. I work with Tortoise Git, and what that means is that if you look at it now, I right click on a folder, Windows folder, and it pops up with a context menu, and it's integrating with Explorer. So I like it the most because it integrates with Explorer. I can right click and then hit git clone and then OK, and that's it. With a console as alternative, but then you would need to know how to use console. You can open it in a console, so equivalent would be you would first need to navigate to this place, and then you would need to call some git commands to do the same that the UI tool did for you. Console is nice to familiarize yourself with how it works. So I navigate it, then I say git clone the stuff. Sorry, the link to my repo, .git, and it clones it, copies it, binds it. Well, a bunch of commands. I'm not using console myself that often, so I'm having a hard time to memorize everything. But that's it. That's all it takes.
Okay. Alright, you stopped streaming, by the way.
Did I?
I don't know. Yeah, I don't know if you shut the stream down on purpose or what, but
I didn't.
yeah.